Good morning, children. Study of compounds is the first chapter in grade 10 devoted to the study of inorganic chemistry. It deals with hydrogen chloride, ammonia and ammonium hydroxide, sulfuric acid, and nitric acid, preparation, properties, and reactions. So, first up, we have hydrogen chloride to be discussed at length in this section. Hydrogen chloride is a gas at room temperature. German chemist Johann Glauber (1604–1668) prepared hydrogen chloride by heating common salt, that is sodium chloride, with ferrous sulfate. It was prepared by Joseph Priestley in 1772, and Humphrey Davy in 1810 confirmed that it contained hydrogen and chlorine. It is also called muriatic acid. Muriatic relates to brine. And you can see that brine is a concentrated solution of sodium chloride, which is common salt in water. The name hydrochloric acid, a solution of hydrogen chloride in water, was coined by Joseph Louis Gay-Lussac of France in 1814. Methods of preparation are as follows. By addition reaction between hydrogen and chlorine in the presence of moisture, which acts as a catalyst. So H2 plus Cl2 gives 2HCl. By chlorination of hydrocarbons as a byproduct, the byproduct is HCl. So methane reacts with chlorine in presence of diffuse sunlight, which is not necessary here to be mentioned. It gives methyl chloride and HCl. You have to separate these two gases. The reaction between sodium chloride and concentrated sulfuric acid at controlled temperature. Twice NaCl plus concentrated H2SO4 gives NaHSO4 plus HCl gas. Generally by reacting any metal chloride with concentrated sulfuric acid. The lab preparation or the laboratory preparation of HCl gas is as follows. In the laboratory, hydrogen chloride gas is prepared by heating a mixture of sodium chloride and concentrated sulfuric acid below 200 degrees centigrade. This is done to avoid the formation of sodium sulfate that fuses with the glass and spoils the apparatus. So temperature should be controlled and kept to 180 degrees, that is below 200 degrees centigrade. Also, the apparatus may explode at temperature above 180 or 200 degrees centigrade. Apparatus may explode, and a higher temperature leads to wastage of energy. So these are the other 2 points which must be kept in mind when producing HCl gas by this reaction. The gas evolved is dried by passing it through a bottle of concentrated sulfuric acid and is collected by upward displacement of air, as it is heavier than air. Now this is the diagram of preparation of HCl gas. We have a conical flask with a double-holed rubber bung or a stopper. Through one of these holes, there is a thistle funnel inserted into the conical flask, and through another hole, there is a delivery tube fixed which connects the conical flask where the reaction is going to occur to a Wolf bottle containing concentrated sulfuric acid. As the acid comes down and reacts with sodium chloride kept here, the gas is evolved and is passed through, it's collected and it goes through, or it is led through this delivery tube into a Wolf bottle, into which the delivery tube dips inside the level of the concentrated sulfuric acid. Concentrated sulfuric acid dries up the gas, and the dried gas which bubbles out is led into a gas jar and is collected by upward displacement of air, as it is heavier than air. The sodium chloride is taken in a conical flask fitted with a thistle funnel and a delivery tube connected to a Wolf's bottle containing concentrated sulfuric acid. Concentrated sulfuric acid is allowed to fall on the sodium chloride slowly. Brisk reaction occurs and whitish fumes are evolved. These fumes pass through the Wolf's bottle containing concentrated sulfuric acid, where moisture is absorbed and dried gas is collected in a flask by upward displacement of air, as shown in the diagram above. In the previous slide, the temperature is maintained below 200 degrees centigrade to prevent the formation of sodium sulfate, which fuses with the glass, rendering it unfit for further use. The reaction is as follows: NaHSO4 plus NaCl gives Na2SO4 plus HCl, but this compound, it fuses with the glass material and makes it unusable. Further, properties of hydrogen chloride. Now, these are some of the physical properties and also a little bit of its interaction with the man who is near by its production site. So HCl is highly soluble in water. HCl is heavier than air, so collected by upward displacement of air. Hydrogen chloride gas has a suffocating odor and is colorless, and it is pungent too. So one must take precautions while preparing a sample of it. The apparatus must be airtight because the gas destroys the mucous lining if inhaled of the nasal passage, throat, and lungs if it goes that deep into the body. And anybody who inhales it must run out into open air to breathe. It causes irritation of skin too. HCl is neither combustible nor a supporter of combustion. The choice of drying agent, only concentrated sulfuric acid is used. Phosphorus pentoxide P2O5 and calcium oxide CaO cannot be used as they react with HCl. In this diagram, we see that HCl is heavier than air as it displaces air. And since it is incombustible, nor it supports combustion, this flame goes out as a jar of HCl is poured over another jar containing a burning candle. The candle goes off, proving that HCl is heavier than air, and at the same time it is non-combustible. It does not burn even if fire is shown to it. So that's it, and we shall see the reaction of HCl with compounds and metals in the next lecture and in the next video. Thank you very much. Please do comment and pass on your suggestions to me for improvement of these lectures. Ultimately, they are going to help you out. Thank you very much.